Welcome back, and we are continuing with question 7 now. We'll be doing Euclidean geometry. They say complete the statement so that it is true. The line drawn from the midpoint of one side of a triangle parallel to the second side. So we've got a triangle there. Then they say the line is drawn from the midpoint of one side. So it's a midpoint. Then we draw a line like that. And then they say it's parallel to the second side. So obviously this one can be parallel to this one. So what does it do to this third side? So it obviously bisects the third side. Because we do know the midpoint theorem. It says if a line is drawn joining the midpoints of two sides of a triangle, then that side is parallel to the third one and equals to half its length. So that means this one is also the midpoint. This point is also a midpoint. So it bisects the third side. 7.2. ACS is a triangle. So this is ACS. That's the triangle they're talking about. P is a point on AS. This is P. It's a point on AS. And R is a point on AC, such that PSQ or PSRQ is a parallelogram. So we know that this side is parallel to this one and also equals to its length. And then also this one is equals to this one because it's a parallelogram, and also this one is parallel to this one. That is what a parallelogram is. It is a quadrilateral that has both pairs of both sides parallel and equal to each other. And then PQ intersects SQ, or PQ intersects AC at B. So this is PQ, it intersects AC at B. Also such that B is the midpoint of AR. So that means this one is equals to this one. And then they say QC is joined. So this is QC. Also CR equals PS. So CR, where is CR? This is CR. It is equals to PS. So they already showed that. C1 is equals to 50 degrees. So this one is 50 degrees. And then they say BP is 60 millimeters. So it's 60 millimeters there. And then they say to calculate the size of angle A. Now, as we can see, in order for us to find this angle, we have to use the given information. Now, if we look at this, we are going to see that we are given angle C1. Now, since we've got angle C1 that is 50, we have to use angle C1. But now, with our angle C1, we've got a bit of a problem here. We are looking for this one, and if we look at angle A, and we know that we've got parallel lines, obviously if we have parallel lines here, we have to think of three things. Those are your alternate angles, your co-interior angles, and your corresponding angles. Now looking at A, we can see that A is actually equal to R3. Because they are alternate angles, since they are between parallel lines, that means they must be equal. So if we can solve R3, we'll definitely have A. Now let's see what we can do. Now with this, we're told that RC is equals to PS, we're told here. So we can actually use that, since also this one is equals to this one, since they're opposite sides of a parallelogram. So if this one is equals to this one, that means this angle is equals to this angle, and then we can solve for this angle because we know that it's the exterior, so it's going to be the sum of these two angles, and then after finding this one, we actually have our angle A. So we are going to say CR is equals to PS. We were given that, and then we know that QR is equals to PS because they are opposite sides of a parallelogram. And then, as you can see, this is PS, this is PS, so that means CR is actually equals to QR. So therefore, CR is equals to QR. So CR is equals to QR, and then it simply means angle C1 is equals to angle Q1. They are both equals to 50 degrees. Since it's angles opposite equal sides. Then from there we can now say angle R3 is equals to angle Q1 plus angle C1, which is 100, that is 50 plus 50, and the reason for this statement is the exterior angle of a triangle. It is equals to the sum of the opposite interior angles. Therefore, okay, by the way, we can now say angle A is equals to angle R3. The reason it's alternate angles. Remember, alternate angles are only equal if they're between parallel lines. So give us the parallel lines that make these alternate angles to be equal. So that is QR is parallel to AS, which is the same as PS. By the way, they are the same line. So we can just say AS. And then that means our angle A is equals to 100, which is that one. Now we go to 7.2.2. Determine the length of QP. Now you can see QP is this line. Since now we were given BP, that it's 60 millimeters, and also this one is parallel to this one, so that actually tells us that we've got ourselves a midpoint theorem. So that means this one is going to be 120, because we know that this third side is equals to twice the length of this one, which is the one that is joining the midpoints of two sides of a triangle. So now we can say RS is equals to 2 times BP, because it's midpoint theorem. So that means RS is equals to 2 times 60 millimeters, which is 120 millimeter. If this is 120 millimeter, and we know that PSRQ is a parallelogram, that means RS is actually equals to QP, since they are opposite sides of a parallelogram. So we say RS is equals to QP is equals to 120 millimeters. The reason behind that is opposite sides of a parallelogram. They are always equal in length. And now we go to question 8. ABCD is a parallelogram. ABCD is a parallelogram. E and F are points on AB. This is E and this is F. There are points on A, B, and DC respectively such that AE is equals to CF. As you can see, AE is equals to CF. DE is produced to J, so DE is drawn and it goes to that point which is J, and then CJ is drawn. And then BF is produced to K, BF is produced to K, and AK is drawn. Prove that DJ, this one, is parallel to BK. Now one thing we can do is to prove that this here FB, it's EBFD is a parallelogram. If it's a parallelogram, that will mean this is parallel to this one, which is basically what they want us to prove. So let's see if we can prove that this is a parallelogram. So we'll have to prove that this EB is equals to DF. Now since AB is equals to DC, because we do know that it's opposite sides of a parallelogram, since they told us that ABCD is a parallelogram, so we can say AB equals DC, and then it's opposite sides of a parallelogram. Then from there we say, remember AB can be written as AE plus EB, and this one can also be written as CF plus DF. CF plus DF. Now since this one and this one are equal, that will tell us that these two are also equal, since when we add two equal things they give us the same value. So we can now say therefore EB is equals to DF. So one side is now equal. The one pair of opposite side is equal. And also we know that this is parallel to this one because they're opposite sides of a parallelogram, which was ABCD. So EB is parallel to DF because they're opposite sides of a parallelogram. Therefore, we can now say EBFD is a parallelogram because one pair of opposite sides is both parallel and equal. So we do know that. Therefore, since EB is actually since this is a parallelogram, that means this one is parallel to that one, which means DE, since DE is DJ produced and BF is BK produced, that means we actually proved this. So DJ is parallel to BK because they're opposite sides of a parallelogram. Or you can start by saying DE is parallel to BF, and then you write this reason there. Yeah, I think we can actually see that there. So let me just move this to here and then this below. So we can do it like that. And then we go to 8.1.2. Prove that E1 is equals to F1. So this is E1 and then this is F1. So now we have to try and find one angle that is equal to both these. Now, which angle is equal to both E1 and F1? Now, as we can see, we already know that this is parallel to this one, and this one is parallel to this one as well. Now, we can see that E1 is actually equal to D1 because they are corresponding angles and they are between parallel lines. And also, this D1 is equal to F1 since they are alternate angles, as you can see there. And also, they are between parallel lines. So, we'll use D1 to solve that E1 is equal to F1. So we can say angle E1 is equals to angle D1. The reason behind that is corresponding angles. And also do not forget to give us the parallel lines that make these corresponding equal. So we can say AB is parallel to DC. And then again, angle F1 is equals to angle D1. The reason is alternate angles. Which parallel lines make these alternate to be equal? It's the DJ parallel to BK, which is what we proved on 8.1.1. Now we go to therefore angle E1 is equals to angle F1, which is what we were required to prove. Then now we go to 8.2. Now in 8.2 they say prove that AT is equals to BT. So prove that this is equal to this one. Now if you look at this, they told you that this is equal to this one. And again, you can see that OA and OB, they are equal since they are both radiuses of the same circle, which is a line from the center to the circumference of a circle. So if this one is equal to this one and this one is equal to this one, that means this is actually a kite. APBO is a kite. And if it's a kite, we know that the diagonal between equal sides actually bisects the other diagonal, so we can use that. So we say AP is equals to BP. That was given. And then OA is equals to OB. The reason they are equal radii. And then from there we can now say therefore APBO is a kite. Why is it a kite? Because its adjacent sides. Remember what a kite is? A kite is a quadrilateral that has adjacent sides equal to each other. So its adjacent sides equal. Therefore, AT equals TB because the diagonal between equal sides bisects the other diagonal. Done. Then they say prove that OTA, this one is equals to 90 degrees. Now since we know that APBO is a kite, then we know that the diagonals intersect perpendicularly. So you can just say O angle TA equals 90 degrees because diagonals of a kite intersect perpendicularly. Then we're done like that.